This is Geometry B, Unit 5, Area, and Lesson 6, Circles and Arcs. Today we're going to look at two objectives, finding the measure of central angles and arcs, and finding the circumference and arc length. So measures of angles and arcs, and measures of circumference and arc length. So a couple of things by way of review here in definitions. We're talking about circles, so circles have centers, so let's put a center here on the screen. We call this circle O. O seems like a good choice for a letter for a circle. And we usually indicate the circle center as the letter. Circle O. Okay. And a couple of things to remind ourselves about. We have a circumference. Formula for circumference is 2 pi r. And the formula for area is pi r squared. Okay, so we need those. We also need some understanding of circular arcs, right? A circular arc is a piece of a circle, just a part, from one point to another on the circle. So from one point to another on the circle. So, and actually, let's do it this way here, because what I'm drawing is the radius, and that's not part of the arc. The arc is right here. Okay? And so the arc is a piece of a circle starting at one point, ending at another. Okay? And that's called an arc length, if you please, right? So the measure of arc VA would be the arc length. And the arc length is a unit of distance, just like anything else. It's just distance along a curved path, right? Or the measure of VA, right? We indicate actually the measure of angle VA, or of VA by its central angle. So here we go. Let's draw the radius. I'm getting arc length and the measure of an arc mixed up. Arc length is a distance, but the measure of an arc is its central angle. So let's call this angle theta, right? The measure of arc VA is theta, is the central angle. Okay, so we can indicate, for example, that the measure of the central angle is 65 degrees. We can put it there. We can also put it there, right? The measure of arc VA is 65 degrees, okay, as opposed to arc length. Now, arc length is another matter altogether. Arc length we're going to do as well. Arc length is units long, not degrees long. All right. So let's get into it here, and let's use 65 degrees as my central angle. Okay, 65 degrees. So I'm going to say 65 degrees. Okay, and I'm actually going to put the 65 degrees right here. The same thing, you can put it in either place. Okay, and I'm going to say the radius is what it is here, 245. The radius is 5. Okay, and I'm interested in finding a couple of things. I'm interested in finding the arc length. How long is it from B to A, measuring in inches or square unit, or units? Not square units, that would be area. I'm interested in finding the area of the sector. And so this shape, and there's another word, sector, is a shape formed by an arc and by the radiuses that meet the endpoints of the arc. So it's kind of like a pizza pie slice. That's a sector. Okay. So let's find the arc length. Okay, let's do arc length right here. Arc length. Okay. And here's the model. We're going to do it this way. Part over whole. Part over whole. And we're going to look at the angle as opposed to the length. Arc length. Angle as opposed to length. Okay, So what is the part of the angle? Well, the part of the angle is 65 degrees. 65 degrees. The whole of the angle is the angle it takes to go all the way around, which you know is 360. So part, the angle of the sector divided by the full angle of circling completely around, part over whole, equals length part. We're going to call that S. And for some reason they use S for arc length a lot. Got to make sure your S's don't look like 5s. My S's tend to look like 5s. So arc length divided by the total arc length of a full circle. If we went all the way around the circle, the whole circle, well, that is, according to the formula, 2 pi r. And there it is. That's the key to finding the arc length, setting up this proportion. Now, there are ways to simplify it, but I prefer this way because it's the simplest to explain and understand. So we can cross multiply, right? So cross multiply 360 s, 360s, and that does look like a 5. Okay, 360s equals 65 times 2 pi. And r, the radius, we said was 5. So let's put in 5. 2 pi times 5. Now you might be tempted to multiply things out and simplify things. You can do that. Or you can leave it all in, as I'm doing. The opposite of multiply 360 is divide 360. And so we get this formula. The arc length is 65 times 2 times pi times 5 divided by 360. Okay, there we go. Then this is a formula I can put in on Desmos. Let me try it here. Desmos, oh toodles, Desmos. Okay, that comes from Mickey Mouse Clubhouse. Oh toodles. All right, here we go. Boom. 65 times 2 times 5 divide 360. And you'll notice I left out pi. If they wanted left in terms of pi, you do this, and I would say 1.8 pi. There's no sense in doing that, though. So I'm going to go ahead and put the pi in here. And if you want it to look just like the formula, you can. 65 times 2 times pi times 5. You just have to select it all and then divide by 360. And I've got an error there. 65. There we go. All right. So we get 5.67. So the arc length is about 5.67. Arc length 5.67. Okay? Inches if you're using inches. And it makes sense. What we're saying is this arc length is a little bit longer than the radius. And it does appear to be about that. Okay? All right, so that's arc length. Now let's do area, right? Area. So use the same idea to do it here. We do the part over the whole. Part over whole. We compare the angle, not to the arc length now, but to the total area. Okay? And so here's what the formula looks like. Part of the angle is 65 degrees. The whole angle is 360 degrees, angle of the whole circle. Area of the sector is just A. And the area of the whole circle is pi r squared. Pi r squared. Now r is 5. So pi times 5 squared. Okay? All right, let's go ahead and solve that. So making a little room here, solving, cross multiply. Noticing the video is going a little long here. I'd like to try to keep it to under 10 minutes. All right, so A times 360 equals 65 times pi times 5 squared I'm going to divide by 360. So A is 65 times pi times 5 squared divided by 360. Okay, and there we go. Let's go ahead and pull up Desmos. Okay, 65 times pi times 5 squared, I'm just editing the original, divided by 360 is 14.14. 14.14 square inches. Now, area is in square inches. Arc length is in inches. Okay. And you can, if you want, go back to the original circle. Does this seem to be about 14 squares? And if I count the mostly squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I get 15, but I was a little generous. Okay, that's a good way to check your work to see if it's about what it should be. All right. So that is it. That's the lesson. There we go, right there.